3. This is section 8.7, part 2. We're talking about exponential functions. On this backside, we're going to be practicing graphing an exponential function. So here we have the function y equals 0.5 times 2 to the x. Do you remember that y and f of x are the same thing? So this equation could have just as easily been written f of x equals 0.5 times 2 to the x. Well, to graph an exponential function, we're going to have to try some numbers. I can tell you very simply that the easiest numbers to try are going to be numbers that you recognize and then will plug in easily. Let's start by trying 0. 0.5 times 2 to the 0. By now you realize that 2 to the 0 is 1, so 0.5 times 1 is 0.5. I'm going to write this as a point out here, 0, comma, 0.5, and we're going to graph that. 0.5. Let's look at our second point. Let's use the number 1. So 0.5 times 2 to the first. Well, 1/2 of 2 is 1, so that's the number 1 comma 1. Let's graph that. Let's try the number 2, and let's just continue our pattern. Times 2 squared, 1/2 of 4 is 2. Boy, it looks like 1, 1, 2, 2 just keeps this pattern. Do you think it also continues for 3? Well, let's try. It seems like there's a curve that's starting here. Let's try the number 3. 0.5 times 2 cubed. 1/2 of 8 is 4. So that's 4 comma 8. Well, all of a sudden, that's 3 comma 8. All of a sudden, the numbers are starting to shoot up a little bit faster than before, and you see your curve beginning to go up. If you tried 4, you would see it went up even faster still. That's 4 squared. 1/2 of 16 is 8, and now you have 4 comma 8, which is way up here. So here you have a very steep curve beginning as it goes up on the graph. The question remains, what happens when you go and take some negatives into consideration? Well, let's take a look at some negatives. I'm going to write a -1 up top here. 0.5 times 2 to the -1. You may want to do this on your calculator, or you can just look at the pattern. Each time we're multiplying by 2. 8 to 4, 4 to 2, 2 to 1, 1 to 1/2. Well, that's going to be 1/4. So -1 will be at 1/4, and actually it will continue getting closer and closer to the x-axis, but never ever quite touching it as we go through and finish our negative numbers. So maybe as we're doing these numbers, we should always try maybe 2 negatives and 2 positives. And perhaps on some of these problems we're going to need to have a chart that has more than just 2 or 3 numbers. Let's look at our bottom one. It's a similar equation. It's 0.1 times 3 to the x. So I'm going to start with 0, 1, and 2 as my numbers of choice. But notice this time I've added a box at the bottom, and I've left space for the top for -2 and -1. Let's put in our numbers. 0.1 times 3 to the -2. I'm going to do that on my calculator. 0.1 times 3 raised to the -2. Now when I raise it to the -2, I have to make sure I use parentheses. Well, that's 0.01 repeating. That's 1/100th. I'm not sure how I'm going to graph that. It's a very small number. -2.1. I don't want to touch the x-axis, but I certainly want to get as close as I possibly can to it. I hope I'm going to come off as I go up. 0.1 times 3 to the -1. Well, let's look at what that is. 0.1 times 3 raised to the -1. Well, now it's up to 0.03. It's still extremely small. I'm going to go just a tad higher. And my graph at this point is not very realistic because I can't graph between 1 and 100 of that nature of a point. Well, let's go up to 0. 3 to the 0. Well, 3 to the 0 I know is 1, so now I'm up all the way to 1/10. 1/10. How do I put that? Well, I guess about right there. Well, so far it looks like it's a straight line. Let's go up to 1. 0.1 times 3 to the first. Well, 0.1 times 3 to the first is up to 3/10. Wow, I'm almost up to 1/2. Doesn't seem like there's much of a change. Well, the reason is our starting number is very small. Let's try 2. 0.1 times 3 squared. Well, 3 squared is 9. 0.1 times 9 is 0.9. I'm finally starting to get higher. I really want to see where the curve starts, so I'm going to continue my pattern until I really see the curve. 0.1 times 27, well, now I'm up to 2.7. Finally, the curve begins. I'm going to try one last number, 0.1 times 3 to the fourth. Well, 3 to the fourth is 81, and 1/10 of that is 8.1. So finally, I get up to 8.1. So 4, 1, 2, 3, 4, 5, 6, 7, 8.1, and finally I see my curve. So, where your curve is going to change is really going to have to do with your starting number and your multiplier. The higher your multiplier, the higher your curve. So you may need to put in 6, 7 points until you see development either on the left side, the negatives, or the right side, the positives, as you're practicing graphing these exponential curves.